Wow, that was crazy. Wait, what just happened? All right, are we rolling? All right, let's go, come on. Now, this metal we're dealing with here, it's pretty special. It's called sodium metal. Got a little bit of it in this tin right here. Here, I'll give you a little look. Don't worry, it's oil, not water. So this metal, oh, this is a lot of oil. When this metal is pretty cool. If you look, I mean, it looks just like a regular metal, right? But look, I can even cut it with a butter knife. All right, now come with me, and I'll tell you some things about this metal. This metal is right here on the periodic table. And there's something pretty special about this metal right here. And I'm sure you can guess, because you've already seen it, but when I put this metal into this water right here, it explodes. Pretty cool, huh? So now, the sodium metal in its solid state has this one electron on its outermost shell, or its valence electron. But when you put that sodium metal into this bucket of water right here, that sodium metal dissolves. And those little sodium particles in the water, called ions, don't have that one little electron. And that makes the atom much more stable. And when it becomes much more stable, it releases a lot of energy. And by energy, I mean heat. The reaction of the sodium metal with the water also creates a gas, hydrogen gas. And that hydrogen gas, along with the oxygen in the air, gets ignited by the massive amount of heat released by the reaction. And that causes the explosion that you see. So, just to recap, when the sodium metal dissolves, it releases a lot of energy, and it also produces hydrogen gas. That hydrogen gas reacts with the oxygen in the air and ignites from the lots of energy that was produced by the reaction. And then, boom, an explosion. Now, we know how that explosion works, but what about another kind of explosion? Well, to help explain that, here's my chemistry teacher. Say hi, chemistry teacher.
Hi, everybody.
Now, my chemistry teacher here is heating up a vial of something called paraffin wax. Now, there's a bunch of stuff you can do with this wax. You can make candles or relieve dry skin or a bunch of other stuff nobody really cares about. But when you heat it up and you stick it into cold water, it does that. Pretty cool. So now, why did that happen? We stuck a hot vial into cold water and it exploded. It doesn't make much sense, does it? Alright, let me explain it to you. So, when you start heating up the wax initially, it produces a vapor. And then when you stick it in the cold water, the wax particles start to move a little bit slower. And when they move a little bit slower, the attractions between the molecules become a lot stronger. And those formations of those bonds releases a lot of energy, which ignites the vapor and causes the explosion. So now I know about those fancy chemical reactions with metal and wax and a bunch of other stuff, but what about a real explosion with something like dynamite? Oh, I don't have any dynamite. You thought I was gonna buy dynamite? What? No, here, come with me. I'll put a cool graphic up on screen. Watch this. So, this is a stick of dynamite right here. When you light the wick of the dynamite on fire, it starts a reaction with this molecule called nitroglycerin. Now, when that nitroglycerin is lit and heated, it starts to decompose very rapidly into a bunch of different gases: water vapor, carbon dioxide, and nitrogen gas. And because it produces so much gas, it expands very rapidly. And since it's so hot from the fire, from the wick, it ignites and causes the explosion you see. So I think we can see a pattern here. You have a chemical reaction which produces a lot of gas and also a source of heat, either from the reaction itself or from an external source. When the gas expands and ignites due to the large amount of heat in the reaction, either from the reaction itself or from the external source, which causes the explosion that you see. Pretty cool, huh? Oh, where did I put that sodium?